Hi everybody and welcome to episode 2 of the ion chromatography video series. In this episode we're going to talk about starting a run. So let's get into it.
So if you want to start an IC run, the first thing you need to do is make sure that your samples are prepared in the correct way. We talked about this in the last video, so if you haven't seen that, go back and check it out. Make sure you know what you're doing. To summarize it, you need to make sure that the highest ion concentration in your sample is below 100 parts per million or milligrams per liter. And you need to make sure that your sample is filtered. So one way that you can filter is with these syringe filters. It needs to be at least 0.45 micron. It can be smaller, like 0.2. Sometimes you can vacuum filter and sometimes you can centrifuge. But talk to the people who manage your IC to make sure that that's okay first. Once your samples are prepared, you need to put them in the correct vials. So the correct vial is this small blue vial. It has a little blue cap and a plastic body to it. You might think that these HPLC vials are fine because they're almost the same size, but there's actually an important difference. They are slightly different heights, and the holes in the top are slightly different size. This makes a huge difference for the auto sampler. When the needle is trying to inject your sample, it might bump into the top, even if there's just that small height difference, or it might miss the hole if the hole is a different size. So make sure that you've got the right vials, and if you need those vials, here's the part number right here. You can pause the video and order that if you need it. Once your samples are in the right vials, you need to make a calibration curve. Now I'm not going to walk you through how to make dilutions and stuff. We should know C1V1 equals C2V2, but I will tell you that the easiest way to make a calibration curve if you're not making it from raw salts is by using these Dinex 7 anion standard and Dinex 6 cation standard. These have different concentrations of different ions in them, and you can really easily just dilute them to the values that you need. When you make a calibration curve, you usually want to have one point up about as high as the instrument can measure, around 100 BPM, one point somewhere in the middle, and then a majority of them should be in your measurement range. So if you're trying to go into the parts per billion range, make sure that your calibration plot goes that low. If you're trying to measure in the middle, just make sure that your calibration covers that. So an example calibration curve that I make when I'm trying to measure phosphate would be somewhere like 1, 5, 25, 50, and 100 parts per million. And then the other ions, you can just look at the bottle and figure out what concentration those are as well. So once you've got your calibration curve made, now it's time to load the auto sampler. So let's see how we do that. Alright, so this right here is the auto sampler, and we're going to take a look inside. You can see that there's these different trays, and it spins around, and the needle right here can pick out of any of these samples in each tray. You can see that the trays have different colors. Now the color is back here. You can see the green, blue, and red. And we put tape on the front of these so that we know which tray goes where. And you'll also see that there's different vial sizes. So like these ones are large. I believe they're 10 milliliters. And we use this for like our DI waters right here, our anion calibration standards, and our cation calibration standards. And then these blue and green slots we use for our actual samples. And just remember that you put your calibration curve in the red one, anions right here, cations right here, and then DIs right here. So just as an example, let's fill this green one right now. Alright, so I've got my tray out and I've got my 3 samples that I want to run. Let's take a look at this tray. You can see that there's the letters A through E and 1 through 8 right here. I'm going to put my samples in these 3 spots down here at the bottom. So these are someone else's samples. You don't usually want to touch other people's samples unless they're done running and you know that it's okay to toss them out. So when I input these locations in the instrument, I'm going to have to specify that it's the green tray, it's in row E, and it's in spots 1, 2, and 3. So this is going to be GE1, GE2, and GE3. And we'll have to remember those numbers later for when we're making our run sequence. And it's actually important to not put tape on your samples. If you put tiny pieces of tape like this, it's fine as long as it's above the top. But normally, this can actually make them get stuck inside the tray, which makes them really annoying to take out. And it's also harder to wash the vials when you have that. So try to avoid that. So you might be thinking, if I can't put tape on them and I don't want to write on them in Sharpie because I'm going to reuse them, how should I remember where my samples are? Well, write it in your notebook. Write in your notebook which sample is in which position. That's the easiest way to remember where you put your samples. Okay, so now we have to get the IC ready to run. And the IC is going to take a little while to equilibrate, so we want to get this all set up before we start creating our run program. The number one thing that you need to pay attention to before you run the IC is those bottles of water up there. Now these have been running for a little while, so you can see that they're almost empty. These need to be filled with nano pure water. The easiest way to do that is to come over here, or wherever your nano pure station is, and fill up something like this with your nano pure water. So let's do that really quick. All right, so now that our water pitcher is full, let's take it back over to the IC and fill up these bottles. Now, there is a trick to filling up these bottles. You have to think, most of the time when you're going to be filling these up, the pumps are going to be running. So it's going to be continuously drawing out of these lines. Now you don't want to pull these lines out because then it'll draw air into the instrument. You want to slightly open this up and just move it to the side a little bit so that you can slowly pour your water in. And you'll have to do this twice, once for cations and once for anions. And you will need to do this at least once every 24 hours. When the instrument is running at 1 milliliter per minute, this is very important, you have to fill these up once every 24 hours. So if you do a long run that's going to take 3 or 4 days, you need to come in every day and fill up these bottles. That is key, or else the machine will start drawing air, it'll cancel your run, and it's going to take a ton of time to get the machine back up and running. Alright, so those bottles are filled. Now the next thing we need to do is prime the pumps. And this means that we're going to get the system full of liquid, make sure that there's no air bubbles in the system, obviously because air is bad for the system, before we start the run. So, you won't always need to do this. You'll only need to do it when the pumps are off. So if we look here, and we'll talk about this software a little bit later, but if you can see that it's red here, it means the pump is off. Normally, and hopefully if someone is running the IC correctly, the pumps actually won't go off. It'll be kept in a low flow, what's called idle mode, but that is not the case right now, just so I can teach you. So let's prime the pumps. The first thing we need to do is open up this pump compartment, and we need to open these prime valves. So just one little half turn to the left for both of them, a little half turn. And then we're going to come into our instruments. Now this is the cation side, and I'm going to hit prime right here. Now it's going to give me a warning. Purging will deliver a high flow to your system. Make sure that the purge valve is open. We just did that, so I'm going to say execute. You'll hear that noise. And now it is priming. Now we need to do the same thing for the anion side. Again, don't worry too much about this software. We're going to cover that in just a second here. But same thing, right? We open both the valves, so we're going to prime them both. Same thing, execute despite warnings. Now, this will take about 5 minutes. So as soon as that's done, I will tell you what the next thing to do is. Okay, so our pumps have finished priming, and we know that because the little blue lights up here that say prime are not lit. So we're going to close our purge valves right now. Now, you don't want to close these too tight. Just enough to be snug, just as soon as it catches, that's tight enough. It does not take very much. Our pumps are primed, our bottles are filled, and we are now ready to look at the Chromeleon software. So let's dig into it. Alright, so welcome to the Chromeleon software. So here's the home screen for the Chromeleon software. You can see that we have 3 main tabs right down here. They are Instruments, Data, and eWorkflows. This eWorkflows is not important. We are not going to use it. Some people might, but we do not. So Instruments, this is how we control the instruments, right? You can see that there's an anions and a cations instrument. They run as completely separate systems, different from one another. They are not connected in almost any way other than by this software. The Data tab, this is where we set up our sample runs. It's where we tell the instrument, hey, this is where I put all my samples, and this is the type of analysis that I want you to do on it. So we will be messing with that after we get the instrument ready to run. And we need to set up both the anions and cations side. You can see in the bottom right of this tab, there's a little guy that kind of mimics the instrument. You can't see it right now, but if you go back to earlier in the video, you'd see that this is actually oriented in the exact same way that the instrument is set up in real life. The pumps are on top up here, so like this says pump on the top. Remember when we opened that purge valve? And then the cation side, the pump is actually here on the bottom, like when we opened the cation purge valve. Also, this is down here where the eluent generator cartridges sit, and this is where our columns sit. And this is called the TC compartment because it is temperature controlled. If you only want to run one type of analysis, you only need to mess with one of these sides. But if you want to run both, you do need to get both of them ready to run. We have all these tabs at the top for both cations and anions. Each one corresponds to a different piece of equipment in the instrument. So this one is for the auto sampler, and there's a ton of settings on each of these, so don't get too concerned yet. This one's for the pumps. This one's for the eluent generator. This means detector compartment. This means conductivity detector. This is one of the most important ones. And these three aren't super important, but we'll talk about them later if we end up needing them. For the most part right now, we're just going to be working on this home screen for both the anions and the cation side. So these figures down here are how we control the main settings for the instrument. This includes your flow rate, which is right here, your eluent concentration right here, and your suppressor current, which is right here. These are the three most important settings that you can manage on this instrument. For the most part, everyone is going to be running with the same settings, and it's easier to just write down what they are. For anions, which we have open right now, we're setting this to 1 milliliter per minute flow rate, and we can turn that on. We need 15 millimolar eluent concentration, and we turn both of these on. And then we need our suppressor set to 112 milliamps. Now, these numbers may be different for you if you're running some special type of analysis, but for the most part, this is what we use on this instrument. Now, we got to do the same thing for the cation side. Different numbers, except for this one. So the pump, still 1 milliliter per minute. Eluent generator, 20 millimolar. And suppressor, 59 milliamps. Now, they won't always be right at these values. Normally, they will be in idle mode. So this will be at like 0.1, this will be at 5, and this will be at 5 as well. And that's when the machine is just running in basically slow motion. Right now, they happen to be in the correct at the correct values because someone else was actually running the instrument before I decided to record this video. So if you do plan on using a different run program than anyone else, you can find that run program in the data tab for your samples, open it, and dig through it to find what you want. So again, this is not super important if you're just measuring normal anions and cations. So most likely you'll just need to remember these numbers that I just said, but I'll show you how to do that right now, for example, for this anion. So I'm going to go to data, find an anion run that uses the anion processing method that I want, or instrument method. I'm going to open it up right here. And I know this is a lot, but I will cover it all in detail later. And I'll go to this script editor and just kind of scroll through here until we see all those settings that we wanted, right? So the suppressor recommended current is 112 milliamps. Remember how we set it to 112. Now we got to look for the pump flow rate. Pump flow rate is 1 milliliter per minute, so that's what we set it to. And let's see where it says eluent concentration. It's 15 millimolar. Oh, right here, eluent generator concentration, 15 millimolar. Okay, so let's get out of this guy and go back to our run. So basically we've set the instrument to the settings that we want, and now we need to let it equilibrate, right? We want a really flat baseline before we start the run. And what we look at for that is our conductivity detector. So I'm going to hit auto 0, and then I'm going to monitor baseline. Now this is going to start measuring this number, and this is our signal. And basically we're good to start the instrument when this signal has stopped changing. And you usually want this total signal to be as low as possible. Anything less than 1 is usually a healthy column. Anything less than 0.5 is pretty good. If we can get it down to like 0.2, 0.3, you're doing great. So I'll auto size this, and you can see that it's definitely changing a lot right now, so it is not ready to run. But it's going to plateau out and flatten eventually. That's why we're doing this right now. Here's the same thing for the cation side. Auto 0, monitor baseline, and then I'll auto scale this. And once both of these have stopped changing, that means we're ready to run. But it does take anywhere between 5 and 30 minutes. So that's why we do it now, so that we can set up our run. Okay, so now let's talk about setting up and starting a run. So now that we've got all of our settings set correctly, we come in here into our data and we are going to actually set up our run. The easiest way to make a run is to just copy someone else's. I usually take the most recent run that somebody has done, so like this one was going right now, but I stopped it so that I could record this video, and you just copy it and you paste it. So if you don't have a folder here, you should make one or have someone make one for you. But for example, this was Rebecca's run. I'm going to put this into my folder. I'm going to paste it in here so that all my work is in my own folder. And I have one folder for anions and one folder for cations. You will have to set up these runs separately. So I have pasted their run in here, but now I have all their data too, and I don't want any of their data. So the easiest way to do that is to change this to idle, which basically means, oh, I haven't run, and then fill down. And this fill down button right here is super useful. It basically makes everything underneath it copy whatever I put in that column. And when I hit save, it's going to say, hey, I'm going to delete all your data. Yep, let's delete all that data. Now, once it loads, now I can actually start messing with these samples. Now, if you remember, I only had 3 samples. So I'm going to delete all of these extra samples that I definitely don't need. Just going to highlight them all and delete them. Now, I do want to keep my idle mode. The idle, every run that you make should end in idle, and it should actually end in 2 DI waters. So I'm going to show you how to insert samples. If you just right click and you hit insert, sample appears. Right click again, sample appears. If you need to load a lot of samples, now these are going to be DI waters, so I can just change the name. If you need to load a lot of samples at once, right, I like to do it 5 at a time. So the normal series that you should do this in is 2 DI waters followed by your calibration curve, followed by 2 DI waters, and then you start measuring samples. And when you measure samples, you should go 5 samples, 2 DIs, 5 samples, 2 DIs. If you look here, I'll save that before I exit it. If you look here, that's what you did. 5 samples, 2 DI waters, 5 samples, 2 DI waters. And you just keep that trend going until you end with 2 DI waters and your idle mode. So you can also just like copy entire segments. You can just copy and paste that in, whatever way you find is easiest. Anyways, once you get all of your samples in there, or enough spaces for your samples and you've got them in the right orders, you can change the names. For me, I'm just going to name them 1, 2, and 3. This is completely fine with me. Once you've got your names in there, you have all your rows and your samples are named, we need to tell the instrument where they are, right? So if you remember, that's what this position is. Let's talk about this type first, actually. So unknowns, it measures it as unknowns. Calibration standards are obviously calibration standards. There are plenty of other options in here, blanks, checks, matrices, spiked and unspiked, but in reality, all of these are run the exact same way except calibration standards. Calibration standards, they're your calibration standards. They use the same instrument method. However, they are used later to make your calibration curve so that you can determine the concentrations for everything else. So I usually keep everything as unknowns except for the calibration standards. So now let's put in all of our locations. Our DI waters, at least for us, are always going to be RA1, RA2, or RA3. So let's make sure that all of our DIs are there. These ones are not, so let's change that to RA1, RA2. And remember, this is just because we put these in the red. These are the big 10 milliliter vials that are in that red tray. And our calibration is right below that, right? So RB1, RB2, RB3, RB4, and RB5. Now, remember we put our samples in, I believe it was GE1, GE2, and GE3. All right. You want to make sure that your instrument method is correct, and we will talk about the differences between an instrument and a processing method in the next video when we talk about how to collect your data. But I'll summarize it right now. The instrument method is how the instrument runs. It is the flow rate, the eluent concentration, etc. The processing method is how you tell the instrument, hey, this is the value for my calibration curve, this is where my peaks are, this is the order that the peaks come out, and this is how I want you to select my peaks. So we have no processing method here, but we will talk about that later. So now this is pretty much ready to run for the anion side. And suppose we want to run both anions and cations. You might be thinking like, oh, I could just copy this and paste it over into my cation run. No, you can't. So it says anions right here. If you just copied and paste this, it would keep that. And it would try to run it as a cation calibration curve. So an easy way to do that, let's do the same thing that we did for our cation. So I'm going to copy Rebecca's. I'm going to paste it into my own file. Now if I want to rename it, I can just like call this test, because this is basically a test. I still have to go through the same process, right? So pay attention. Just changing this to idle, fill it down, and then save. So I'm deleting all the data. Now right here is where we are going to do something that saves us a lot of time, especially if you have a sequence that's really long. So at this point, now I can go back into my other run, and I can just copy everything except the calibration curve and the idle. So I'm going to copy it. Now I'm going to select everything here except for the calibration curve and the idle. And I'm going to paste over it. So now it looks almost exactly the same, and this is so I don't have to rename my samples or change the positions. However, it still says I want to run anions. Now it's on the cation system, but it still says I want to run anions. So I'm just going to fill down the cation instrument method. This will change your idle, and your idle does need to be on the idle mode. So keep that in mind. It should always be cations idle, and this one should always be anions idle. So now we have 2 runs, and they are completely ready to run. So let's go back to our instrument. Let's see how our baseline is doing. If I auto size this, oh look, so something came off of the column. You can see that it's starting to flatten out, right? So it's still changing a little bit. I'll auto zero it again to see if this is actually changing very much. Hey, there's another peak coming off. Something was in this when I stopped it. That's what that means. So anion side, almost a similar thing, or almost the same thing happening right now. It looks like it's flattening out pretty good though. It's not changing too much right here. We'll give it a little bit more time either way, just to make sure that it's good. And then once those are flattened out, actually this one looks like it has completely stopped changing. So that one's pretty ready. And this one is changing real slow anyways. Oh, that wasn't a peak. That was just me auto-zeroing it. All right, so it looks like they're both ready to run. So I can just come in here and hit start. However, this is not a real run. I don't actually want to run this. I'm going to delete it and go back and continue Rebecca's run that I so rudely interrupted when I started making this video. So I can just hit resume right here. It'll tell you need to stop monitoring the baseline before you can run it. And same thing down here. Let's start her cation run back up as well. Oops. Back where it started. Resume. And now we wait. So, a cation run is faster than an anion run. It takes about 20 minutes per sample, whereas the anion run takes about 30 minutes per sample. So if you have a run that's, 105 samples long, you better plan for about 3 days of this instrument running. And definitely be sure to come back once a day to refill those bottles. Collecting our data off of this thing once it's finished running is a completely different beast. So if you are doing that next, be sure to check out the next video on how to collect your data. So thanks for watching. Bye.